We're going to move on to Robert Cook-Deegan now, who's based at our ASU DC office. Bob, are you available?
Yes, I'm here.
Okay, it's over to you, my friend.
So I thought the most useful thing that I would do is talk about the function that is the focus of the course that I'm going to be teaching, which is called technology assessment. And technology assessment is it's not really a discipline, it's not really a method, it's not really a field, it's a function. And the idea of technology assessment was emerged from many, many streams about 6 decades ago. And folks began to notice, when we create these new technologies, they affect not only the people who created them, but they affect the rest of the world. And maybe we should think about what happens in the world when we introduce a new technology and think about the consequences. And that bred an interest in informing people who made policy decisions in particular. So think of members of Congress. Who in the 1970s were confronted with all this stuff that was happening in biotechnology and computing and transportation, and we had just landed on the moon, and all these new technologies are being created, and at the same time we're realizing, oh my gosh, look what happened when we built cars. We shifted from coal and solid fuels to liquid fuels, and look what that did. We paved our roads. We changed where people live by allowing them to easily move to the suburbs. Gosh, these are huge things that happen as a consequence of a new technology. Maybe we should think about the policy decisions that are associated with the introduction of a new technology and try to anticipate the problems that are going to emerge and the opportunities that are going to emerge, and think about how we make pass laws that will accommodate these new technologies. So the field of technology assessment came out as a place that I worked when I first came to Washington, D.C. in the early 1980s, was a place that was created by Congress in 1972 and began to operate in the 1970s. And its name was the Office of Technology Assessment. And Elizabeth Graffey, who you'll hear from next, and I both worked there. And its function was basically to take information about science, technology, engineering, medicine, whiz-bang high-tech stuff that's happening in the world, but all the folks who, were elected to Congress, most of whom have law degrees and hated science when they were undergraduates, kind of afraid of math, and yet almost every policy decision that they make has some sort of interaction with science, technology, medicine, engineering, and fields that they're uncomfortable with. So the place that we work, the Office of Technology Assessment, was created in order to help them think about the technologies that were coming down the rails so that they could be prepared to make policy decisions to deal with that. So if you think about it, that means that technology assessment, you need to know what the technology is, you need to know the science behind it, you need to know the business decisions that are driving it, you need to know the legal environment into which it inserts itself, and you need to know the politics, because after all, the audience that you're writing this work for, or that you're doing this analysis for, is a bunch of people who are elected to pass laws and decide what the federal budget's going to be every year. So they don't have a lot of science and technology expertise, but they need to know enough to know how it relates to the decisions that are going to be made. And that means that if you're doing technology assessment, you need to do a really, really good job of understanding technology, but you also need to match that to why should a policymaker care about that? And what are they going to have to do about it? What kind of laws are going to be affected by this new technology? So just to give you some examples, because that sounds pretty abstract, some examples. I come out, I'm a molecular biologist. I trained in the inherited form of Alzheimer's disease and the molecular genetics of cancer. And I come to Washington, D.C. in the early 1980s and work at this place, OTA, on Capitol Hill, right off of Capitol Hill, dealing with Congress. And what are the technologies that might be emerging from the fields that I knew something about? Well, think about it. In the 1980s, we had just discovered recombinant DNA and DNA sequencing. And the ideas of, oh my gosh, this is really, really powerful stuff, and we're learning how to manipulate DNA, which means we can change organisms. which means, oh my gosh, we've got this whole new field called biotechnology that's emerging from science, but it's very practical because it's about building drugs and new devices and things that affect people's bodies. And guess what? Those drugs and devices are pretty expensive. And who pays for those? Well, the biggest payer for those health goods and services, we spend a $1.3 trillion a year through Medicare, Medicaid, and all sorts of other federal programs that buy the things that are coming out of the innovation process in biomedicine. So the federal government, the US federal government, is the largest purchaser of those services. So guess what? If you're in charge of running the Medicare program, you're going to see a whole succession of new technologies coming at you. They're going to be expensive, and you have to decide, what are we going to pay for? How are we going to decide whether it's worth paying for or not paying for? So that was one strain of technology assessment that became very practical. And but health is just one area. I already gave the example of transportation. Elizabeth will talk about a whole different aspect of technology assessment. But what we'll be doing in the course that that Elizabeth and I will be teaching is trying to bring a focus on collective problem solving, of being really good at understanding the technology, but also being really good at understanding the audience that's trying to understand that technology and the nature of the decisions that need to be made about it, which means inherently that it has to be interdisciplinary, and it's focused on a problem. It's not focused on a discipline. And so we'll be, the framework for the course will be talking to people who go through this in their real lives. For example, in the fall, Marcia McNutt, who's now the president of the National Academy of Sciences, was the head of the US Geological Service at the time when the Deepwater Horizon well blew up in the Gulf of Mexico. And she learned a lot about what do we need to know about a technology when we have to make an emergency decision. Another set of speakers will be the former FDA Commissioner Peggy Hamburg and David Relman, who are doing real-time advice right now to the federal government about how to manage the pandemic for the National Academy of Sciences. So we're going to try to get people who are making real-world decisions, advising real-world policymakers about how they're making those decisions and what is it that they use and what is most useful to them in communicating with policymakers about the decisions that they face. I'll stop there.